Hi guys, so in this video we're going to be finding the derivative of inverse trig. This method is sort of applicable to tan, inverse tan, inverse sine, inverse cos, whatever. It's quite an interesting technique. So say I was to take sine of both sides, be left with sine y equals x. I can now differentiate both sides with respect to x. That's going to give me cosine y dy dx, just using a bit of implicit. That's going to be equal to 1. One thing you need to take note of is whenever we're using trig in differentiation and graphs and calculus, we're using radians. So really key, we're using radians. Now I can divide by cosine y. So dy dx equals 1 over cosine y. Now this isn't ideal. I want a function of x on this right side. I don't want y. So what I can do is I can use this function up here. Square both sides. You get sine squared y equals x squared. This is the same thing as 1 minus cosine squared y. Plusing over cosine squared y and minusing over x squared. I get 1 minus x squared equals cosine squared y. And finally I'm going to square root both sides. So I'm going to get square root of 1 minus x squared equals cosine y. I can then input this, and my derivative is going to be 1 over the square root of 1 minus x squared, like so. Quite an interesting little derivative. This method is applicable to cos, tan, etc. We'll go for an example of tan, but this one's quite interesting. This is inverse sine. Thanks for watching, guys.